Okay, so I'm just going to repeat for the video. So we are on these 2 pages. We put the vocab in yesterday, and we did data, mean, and distribution yesterday. We're working on probability today. This is the little slip that we put underneath our vocab, and what we're writing is going underneath that page right there. All right, so this is the formula to find the probability of an occurrence. The number of desired outcomes, in case you can't read my handwriting, divided by the number of total possible outcomes. So the number of outcomes that we want to happen divided by the total possible number of outcomes times 100 gives us probability, and it will be a percentage. So, for example, I've got a coin. I flip a coin. What's the probability it's going to land on heads? There's one desired outcome because a coin only has 2 sides, heads and tails. So there's one possible desired outcome, landing on heads. But there are 2 outcomes in all, heads or tails. Now here's the thing where we have issues. Okay, when we're doing this, when we do these fractions, it is always, 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 always numerator divided by denominator. Top number divided by bottom number. Sometimes it'll be bigger number divided by smaller number. Sometimes it's going to be smaller number divided by bigger number, but it is always numerator divided by denominator. And so if you ever get on a test and on a question and you're like, oh, wait a minute, I can't remember which numbers I need to divide, pretty much everybody knows that 1/2 is 50%, right? So you can probably work that through there. Okay, 1/2. Is it 1 divided by 2 or 2 divided by 1? What's going to get you to that 0.5, which will get you to the 50%? Okay. Next, let's say I want to roll the dice. I want a 1 or a 2. 1 I'm happy with, 2 I'm happy with, any other number I'm not happy with. The number of desired outcomes, there's 2 desired outcomes, 1 or 2. Either one of those is what I want to roll. So there are 2 desired outcomes. There are 6 sides on a dice, so there are 6 possible outcomes. 2 divided by 6, always, always numerator divided by denominator. 2 divided by 6 gives me 0.33, and I think it's 0.3333 repeating, but we only need 2 numbers after the decimal. Times 100 gives me 33%. How are we so far? Thumbs up, I gotcha. Thumbs down, where am I? Somewhere in the middle, somewhere in the middle. How are we doing? Okay? Ladies, how are we doing? All right. Stay with me here. We have a very short period of time in class, so just stay with me. All right, so now on the top of this, there are 3 example problems. I want you to work through those 3 example problems, and I want you to spell it out, baby steps. Set it up. What are the numbers on the top and bottom? Next, divide it. What do you get? Next times 100. What's your final percent? So baby steps, spell it all the way out. Go ahead and do those 3 problems. Okay, so let's make sure we update our really good resource. So the first one, number of desired. There are 3 red marbles that I could possibly pull out. Whoops, that was cool. So that's how many desired outcomes. Divided by the total number of outcomes, which is 15. 3 divided by 15. Always, always, always. Top number divided by bottom number. That equals 0.2. Actually 0.20, I think, but that's okay. Times 100 gives me 20%. So the next one, I have 10 desired, 10 blue that I could pull out, 15 total. 10 divided by 15, that was the 0.666666 repeating. So that's when we round to 2 numbers after the decimal. Since it's 66666, 0.67. Times 100 gives us 67%. All right, still same bag, still 15 marbles. This time I want to draw a green marble. So it's 2 out of 15. 2 divided by 15 was 0.1333333 times 100, 13%. What questions do you have for me about probability and finding probability? We okay? All right, so take a fourth different color highlighter, highlight probability, box in our example for probability. All right, last term is sample. Please read for us the definition of sample, Lizzie. So this happens a lot in science because, you know, ants, critters, the grass producers. So there's going to be tons of them out there. We don't want to count every single one or measure every single one, so you sample the population. So, an example, and this is on the outside door, so I shut the door of my vocabulary. The population of 40 pom-poms in a bag. So I have those little fuzzy pom-poms in a bag, there are 40 of them. I want to take a sample. I draw out 10. Those 10 represent a sample population. So that doesn't make sense because pom-poms. Okay, so let's think of it in a real world type situation. So long time ago, when I was in college, I was able to be part of a group where we put tracking collars on quail. So we went out, caught a certain number of quail. Let's say we caught 10 quail. We expect there to be 40 in that environment, in that ecosystem. We caught 10. Measured them, weighed them, banded them, measured them, measured the little dookies, determined if they're male or female, with a radio collar on them. Those 10 represented a sample of the population. We don't have to measure all quail. We don't have to measure all 40. Try to capture all 40 first of all, and then get data from all of them. We only captured a sample of them. Yeah, better data. Collars on them, release them, and then we can track them, and they would take back to their little cubbies, and then we can get on-site data from the cubby. Where are they at? Where are they going? Where are they traveling at? Stuff like that. Didn't have to capture every single one. They only needed a sample because that sample is a good representation of the population. All right. Fifth color highlighter. Highlight the word sample. Box in that information that you put on the outside.